So the process of electrolysis begins when you heat up the zinc chloride. Once the zinc chloride solid is heated, it melts up. And the melting means that the zinc ions and the chloride ions are set free to move. They become mobile. These are the ions that help in the electrical conductivity. They carry the current and therefore help in the completing of the circuit. So the circuit is complete because these ions are now free to move. So as I mentioned, the breaking down, the decomposition begins when you heat up and these two are set free. Then the moment the current passes through, these two ions are attracted as seen in the diagram. Zinc ions being attracted towards the cathode and the chloride ions being attracted towards the anode. That is the beginning of the decomposition process. Because now, once these two have parted ways and the zinc ions are attracted in this particular section and the chloride ions are on the other side, then automatically it means that these two cannot come together because they have already been attracted to the opposite poles. Now, upon completion, or once these two ions move to the opposite charges, there are still different things that will take place. For example, we have the electrical energy from the electrolyte cell, which will decompose the molten substance of zinc chloride, causing what we call a chemical reaction. So it is once the current passes through, that's when the chemical reaction takes place. But simply by heating, it doesn't result into the decomposition. You only melt it. It remains molten zinc chloride. But the moment the current passes through and the ions are attracted to opposite charges, then a chemical reaction starts taking place. The zinc ions, as I mentioned, are attracted to the cathode, while the chloride ions move towards the anode, which is the positive electrode. We had said that on the diagram. Let's see what happens to the zinc ions when they move towards the cathode and so on and so forth. Now, the two chloride ions lose two electrons. Look at this. Electrons are coming in. That means that they are going to be used somewhere. Now, the chloride ions, one chloride ion will lose an electron to form a chloride atom. One chloride ion loses an electron resulting in the formation of a chloride atom. But in this case, the chloride atom has no physical state because the atoms of chlorine do not exist independently. They join up to form molecules. Molecules are more stable, but the atoms are quite unstable. So it means that we shall have two atoms of chlorine losing two electrons to form a molecule of chlorine gas. So there will be chlorine gas that will be formed at the anode. When these two electrons are given out, they're not going to be hanging. Remember that we had the two electrodes. We had the anode and the cathode. Now, if this is, let's say, for example, this is the cathode, and let's say this is the anode, and the chloride ions have been attracted towards this and have left out two electrons on it. That way. So these two electrons, through the connecting wire, will flow through the connecting wire and then move on to the cathode. The moment they hit the cathode, they accumulate around the cathode. So we shall have electrons accumulating around the cathode. Because they were given up to the chloride ions They are flown through the connecting wire and have reached the cathode. Once they accumulate around the cathode, the zinc ions inside the electrolyte are positively charged, and therefore they quickly pick up 2 electrons. So that once they pick the 2 electrons, now they will be deposited on the cathode as zinc atoms. That means that the gray solid of zinc will accumulate around the cathode. This happened because the chloride ions were able to give out electrons at the anode. The electrons went through the connecting wire and then accumulated around the cathode, making the cathode to be slightly negative, and therefore because they are negative, the zinc ions will now acquire these 2 electrons, depositing a gray solid of zinc. At the end of it all, we have chlorine gas being formed at the anode and we have zinc metal being formed at the cathode. Those are 2 products formed from the electrolysis of molten zinc chloride. And this has happened because one of the species, which is chloride ions, gave out electrons which were accepted by the zinc ions, resulting into formation of the zinc metal. So the 2 electrons given at the anode accumulate at the cathode, making it to become slightly negative, and then the zinc ions are attracted to the cathode. They gain the 2 electrons given out at the anode, forming the zinc metal. That's what we just been explaining here. That once the chloride ions give out electrons, they move, accumulate around the cathode, and the zinc ions gain the 2 electrons, forming the zinc metal. Don't forget, in chemistry, positively charged particles are said to have lost electrons. So for them to become atoms, they must regain the metals. So for zinc, in this case, the zinc ions had lost 2 electrons earlier. So for them to go back to form zinc metal, now the zinc, the gray solid, they must regain the electrons to become zinc metal. The equations, half equations, are the electrodes. And as indicated, we have zinc ions gaining the 2 electrons in that formation of zinc metal at the cathode. That's the half equation taking place at the cathode, where the equations are the electrons are being accepted. Then the anode, that's where the electrons are being given out. The 2 chloride ions giving out 2 electrons, resulting in the formation of chlorine gas. That is what happens at the anode. Now we can have another example of electrolysis of multi-substance. In this case, we want to use what we call lead bromide. Lead bromide to bromide. So in the electrolysis of the molten lead to bromide, we shall have lead ions, lead to ions, being attracted to the cathode, while the bromide ions will be attracted towards the anode. Let's put down first the equation. This we have Pb, that is the symbol for lead, then bromide. In solid form, when heated, it forms lead to ions, molten, and bromide ions. Remember that any substance in molten state, the state symbol is L. It's not AQ, it's L, molten substance. It is only AQ if that substance has been dissolved in water, but if it's only molten, then the state symbol is L. So, at the anode, we have the bromide ions, which will be attracted because this is the positive terminal, and therefore the bromide ions, which are negatively charged particles from the electrolyte, will be attracted towards the anode. When they reach the anode, the bromide ions, as earlier, one bromide ion will release one electron, resulting in the formation of one atom of bromine. But don't forget that bromine is a molecule, it exists in molecular form. It's a diatomic molecule. So because of that, we shall have two ions of bromine giving out two electrons, resulting in formation of a molecule of bromine, Br2, a molecule of bromine. Now, this bromine form, remember that the process of electrolysis in the molten substances must only take place when the temperatures are extremely high. That means that substance must continuously remain in a molten state so it can continue being decomposed, implying that bromine formed must be in vapor form. Don't forget that bromine liquid is also available. But in this case, the bromine formed will be in a vapor form because the temperatures are high. So because the process is being carried out at a higher temperature, then what we shall have will be bromine vapor, the state symbol being G. Bromine vapor will be formed at the anode. Then at the cathode, we shall have electro ions attracted towards the cathode. Pb2+,